So in this question, for whatever reason, there's a frictionless ramp, but not only is it being pulled down by gravity, but there's also an extra 10 newtons force, making it accelerate even faster down the ramp. So we will try to calculate that. So it's sliding down that frictionless ramp, but we got an extra 10 newtons, making it go even faster. It says the applied force is pushing the box aimed down the ramp and parallel to it. That's how I knew to draw it that way. Okay, so I will go ahead and draw the free body diagram. So gravity, straight down, but broken up into components. I will define my components at the top right here. Those will be my reference directions. So that's gravity, and I will label this FGY and FGX for those components. All right, there's a normal force, which is going to balance out FGY. This is because the net force in the direction that's perpendicular to the ramp is going to be 0. The box is not going to accelerate 90 degrees to the ramp. It's only going to accelerate parallel to the ramp. So I will use tick marks to indicate that they're equal. And now there is also 10 more newtons of applied force pushing the box. So I'll call that FA, say it equals to 10 newtons. All right, determine the acceleration. So in the y direction, normal force is equal in magnitude to the y component of gravity. I'm just going to write that there because that's true. I don't think we actually need that equation to help answer our question. To answer our question, we look at the x components. So in the x direction, there will be a net force. And the net force is going to be a combination of two things. There is the x component of gravity aiming down the ramp, so I'll write x hat. And there's also an applied force aiming down the ramp, so plus applied force. I'm asked to solve for the acceleration, so I'm going to need to get that into the equation. That's going to come from rewriting F net as ma with Newton's second law. The x component of gravity is mg sine theta. Always is for these ramp questions. In the x direction, and the applied force is, well, it's 10, but I'll just leave it as applied force for now. Okay. Basically, to get the acceleration, I'm going to divide everything by the mass. Divide both sides by mass to cancel out that mass. So it'll be mg sine theta in the x direction plus the applied force divided by the mass. I'll fill in the values now. So the mass is 6, the g is 9.8. Sine of the angle is given as 20 degrees. That's in the x direction. And the applied force is 10 newtons, also in the x direction. So that's good. They're both in the x direction. They can collect the like terms. All divided by the mass of 6. So that big thing goes in the calculator, and that'll just get your final answer there. So just give me a sec to type that in. So I'm getting an answer of 5.0. That would be meters per second squared and in the x direction. It's down the ramp. All right.